Hi everyone, welcome to Lab in its new form. So you have some choices for Lab. You can either listen to this lecture, or we also do have a live lab where I emailed people the link to that. But I just wanted to start out and kind of orient you to our new homepage. At the top, you'll see office hours, and it says click here to make an appointment with me during office hours. And so hopefully this will work. Zoom is a little bit overwhelmed by life right now. I got into a minute ago, but you can click on this and it should take you into Zoom. Always allow that. Continue. And under appointment booking, so I am the teacher, but for you under appointment booking, it will say book an appointment and you will be able to choose me, and then it will show you my available appointment times. So it's not that you just show up on Zoom during office hours. My office hours are blocked out in 15-minute intervals. So you can go there and choose an interval at which you want to talk to me. If those hours don't work for you, you can always make an appointment with me at another time. I'm fairly available, obviously, because we're all home and I hope you're all doing well. Um, this is our lab for today. So it's lab 6. It's due by Sunday, on Sunday by midnight. And then Monday morning, lab 7 will go live. So the first thing, and ideally you want to go through these in order, the first thing is our instructions for completing the lab. And so if you click on instructions for completing lab, I have some buttons here that you're not going to have, but it says open the lab assignment. You can do this in two ways. You can download the PowerPoint version, or you can use the link to the Google assignment. If you click on the Google assignment for the first time, it will ask you to join the class, and then you'll have access to a file that you can open in Google Slides. And then the second step is to watch the lecture or participate in the live lecture, and be sure that you also have your lab open, as sometimes we'll complete part of it together, which we will today. And then you're going to save your lab as a PDF and submit it in the assignment link provided. And then at the end of the module, there's also a PDF of my regular PowerPoint lecture for you to reference. And so this would be a good time. So normally there'll be a video here that says watch lecture, but I'm recording the lecture right now, so it's not up there. But this would be a good time for you to pause this video, either download this as a PowerPoint file for you to complete it in PowerPoint, or get access to the Google Classroom assignment so that you can complete that lab. So make sure that you have that open. You can pause and then come back. But I will move on to our lecture for today. So our lab today is all about circulation systems and weather forecasting. The weather forecasting will actually be more in next lab, but the only thing you need today is your atlas. So I have converted these labs really to be online. A lot of it is kind of a drag and drop things into place. So hopefully this is going to work pretty well. But today you're going to learn to identify global wind and pressure. You're going to identify global ocean currents. You're going to interpolate isobars, and I'll talk about what isobars are. But so we have talked a little bit about pressure in the past, but when you have low pressure, you have warm air that is rising to an area of lower external pressure, and so you get convergence. So right here you have this air coming together, air goes up and rises, and generally you have wetter weather. So low pressure at the surface, clouds in the upper atmosphere. High pressure, you have colder air that is sinking down to an area of higher external pressure, and now you have dry weather right there. And you also have these pressure systems at the surface. So in the northern hemisphere, the Coriolis effect pulls wind, and so it cycles out of high pressure. Air pressure always travels from high to low, always, always, always. So in the northern hemisphere, cycles clockwise out of the high, and then counterclockwise into the low. So we're going to look at some high and low pressure systems as part of your lab. And in the southern hemisphere, it does the same exact thing, except we cycle counterclockwise out of the high and clockwise into the low. So air always, always, always flows from high to low. If you're in my lecture, or I'm sure if you're in Professor Nessa's lecture and the other lectures, you've probably already been talking about pressure gradients. But pressure gradient is just the difference in pressure over a given area that causes wind to move from high to low. So here over Wichita, we measure air pressure in millibars. So this is 1,028 millibars in Wichita. In Columbus, it's 997 millibars. So our wind is moving from this high to this low. And the stronger this pressure gradient, meaning that the bigger the difference over a shorter area, the faster that wind is going to move. So these isobars represent kind of equal values. And if these lines are closer together, if 1020 was closer to 1010 was closer to 1000, this wind would be moving much faster. So the first part is global wind and pressure systems. We're going to do part of it together, and then part of it you're going to do on your own. So I'm going to move over now to my lab, which I have open here in Google Slides. So if you opened up your lab, you can see here is the first page of my lab. Let me see if I can hide this. Nope, it's not going to let me. Can I zoom in? Sometimes when I'm recording lecture, it doesn't really want to let me do what I want to do. There we go. Okay, so at any point in the lab, if you see a red box like this, it means you are going to have to input some type of information in that box. So this text you should not be able to move. This is true on the PowerPoint as well. So ideally, you're going to put your name in here, which I'll put my name for an example. And so much of this looks a lot like your lab manual did. So we have our objectives and terms for today. I just talked about our low pressure and high pressure, and that air always flows from high to low. If we move on to page 2, part of the lab assignment, it says fill in the global wind and pressure figure A, together in class or along with the recorded lecture. So that's the first thing that we're going to do. So all of the figures are towards the end of the lab. So here is figure A, which looks like a hot mess, but I promise you it is not. So I'm going to fit it into here right now. So I actually decided to move over to PowerPoint because it gives me a little bit more screen room than Google Slides does on my laptop. But okay, so this is our Earth right here. Right here is our latitude 60 degrees north, 30 degrees north, our equator at 0, 30 degrees south, 60 degrees south, and our south pole. So we have a red box here, so we are going to insert our pressure systems here. So let's start at the equator. And so in this box, you're going to write equatorial low. So we have this constant low pressure near the equator that kind of goes a little bit south and a little bit north dependent upon the season, but we have this low pressure. Then at 30 degrees north and 30 degrees south, we have the subtropical high. And then at 60 degrees north and 60 degrees south, we have a band of low pressure called the subpolar low. Which I realize that now I'm missing one there, but I can easily fix that. Put that there. I'll fix it for you. And then at the poles, we have constant high pressure. We have the polar high. Antarctica is actually very dry. It's the world's largest desert. It's just always frozen. So we can see these kind of little wind patterns here that I've put on this, but when you have high pressure in the northern hemisphere, you have air cycling out of the high in a clockwise manner. At the equator, we have it cycling in because it's low pressure, cycling out, high pressure, cycling in, low pressure, cycling out, high pressure. And so the first thing that we're going to do is put the trade winds where they belong. So the trade winds are winds that flow from the subtropical high to the equatorial low. So these guys are going to be in the northern hemisphere. Boop. Not you. You. These guys are going to be in the southern hemisphere. So we have these constant trade winds that are blowing from our subtropical high all the way to our equatorial low. Then, also coming out of our subtropical high, we have something called the westerlies. These are winds that come from the west and they flow towards the subpolar low. So they should look like this in the northern hemisphere, and then like this in the southern hemisphere. So normally in class we would be drawing this with our colored pencils, but alas, we don't have colored pencils on the computer. And then the last is the easterlies. The easterlies flow from the from the polar high to the subpolar low. So in the northern hemisphere it would look like this. And in the southern hemisphere, they would look like this. So these are our global wind patterns, right? We have our polar high, our subpolar low, high, low, high, low, high. Winds coming out of the highs and into the lows. Our red arrows are our trade winds. Our purple arrows are our westerlies, and our green arrows are our easterlies. So you are going to, so that's the part of the lab assignment that we did together. And then on figure B, you are going to drag and drop these locations on a world map. The subtropical high is red hatch marks, the trade winds are green arrows, the westerlies are purple arrows, and the ITCZ is a blue heavy line. So it tells you kind of where to put those. And if you scroll down to figure B, you can see I have the northern hemisphere ones up here, most of the southern hemisphere ones down here. Here's my ITCZ line. And you can just drag and drop these guys where they're supposed to be on this map. So that's what figure B is. Let's go back to my lecture now. So this says do this on map from lab 5. We're not doing it on map from lab 5, obviously, but we have global ocean currents that also affect weather. So if you're on a warm current, your weather is going to be warmer than if you are on a cold current. And so you are going to make a map, and I will send this map back to you and you will be using it in the next lab as well. But let me find this page. On this page of the lab, it says, I want to go back to my PowerPoint one, sorry, where I can see better. There we go. So it says, using the second world map, figure C, label the ocean currents listed below according to the directions. Ocean currents on the map are all currently black. Find the ocean currents listed below in your atlas. So this is what you need your atlas for. Change the current to blue if it is a cold current and red if it is a warm current. Do not move the currents. So if we scroll down to that next figure, we have a bunch of ocean currents here. And if you click on them, there we go. I guess I'll click on this one. If you click on them, you can change their color. So here it is shape outline in PowerPoint. So I will give you this one. It is a warm current, so we will change it to red. If you are in Google Slides, go back over here. And the Google Slides arrows are a little wonkier, but they still work. You are going to go to this button right here, line color, and change it to a red. So you're going to go through all of these currents. You don't have to label them like word-wise. You just have to find out if they're a warm or a cold current. So find these currents in your atlas, and then at the end, all of these arrows should either be blue or red. And then part 3 of the lab is about those isobars that I talked about before. So isobars are iso lines that represent equal intervals of air pressure. And so everything on this line has an air pressure of 1016. Everything on this line has an air pressure of 1020. When you have circles that go in like this, right, we have high pressure here. This is the highest ones. This is a high pressure cell. And over here, this is the lowest one. Now we have a low pressure cell here. And if we go back to our lab, not this lab, let's go to the other lab because it's a little nicer. Boop. So this is an explanation all about isobars and pressure, and so you should read through this just like you would normally in a lab. So normally in the lab you actually have to draw the iso lines, but that's a little impossible on the computer, so I'm not making you do it. So you should be quite happy because students generally don't like it. So instead what I have done is, here is the figure, and I have drawn those isobar lines on this map. And so here are the things that you are going to drag and drop. And the explanation of where you're dragging and dropping it and where it goes is listed here. So the H on top of the center of high pressure cell, the L to the center of low pressure, the green arrows that show the general flow of air, and the red arrow where the wind speed is the fastest. Remember, wind speed is fastest when that pressure gradient is strongest, when those isobars are very close together. And then blue arrow where the wind speed is slow. And you're going to want to rotate that arrow to those arrows so the wind is moving in the right direction. And it looks just the same in our Google Slides one here. Boop. So you're just going to have to drag and drop. This is all one item here, this little pressure cell. So that is it for the lecture for Lab 6. Please email me if you have questions. In order to submit the lab in Google Slides, you would go to File, Download as a PDF, or in PowerPoint, you would go to File, Save as an Adobe PDF. You're going to save that PDF, and then back on our Canvas homepage, you are going to click where it says Submit Lab 6 here as a PDF, and you're going to upload it there. Again, it's due by Sunday at midnight. I hope you all are well. Email me if you have any questions, and good luck.